Hi guys, so today we'll be looking at natural logs, and we'll be looking at the graph of y equal to ln x, which is another way of saying natural log, and the reflection of the graph y equal to e to the power of x in the line y equal to x. So if you recall from previous video on exponentials, we know that e to the power of x graph looks something like this, and this exponential goes through this point 0, 1. Now the notation ln means the logarithm to the base of e, and is also on your calculator. Because this has a special base, rather than writing log to the base e, we just write ln. So this means natural log of base e. So log to the base ex is ln x, or natural log x. Now we could compare the graphs of y equal to x and y equal to ln x. So if we draw the reflection line y equal to x and reflect this, we get this graph here y equal to ln x. So if it goes through the point 0, 1 for e to the x, ln x will go through 1, 0. So you can see here the domain and range, or the value coordinate 0, 1 and 1, 0. You can see the pattern here. Okay, so natural logs. So the inverse of y equal e to the x is y equal to ln x. So if we take ln of e to the x, it will be just x. If you take e to the ln x, it will be just x. Okay, so here it says solve e to the power of x equals to 5. So if you just take ln on both sides, so ln and e will cancel out, so it leaves you x equals to ln 5 on the right hand side. Alright, let's have a look at the next one. So it says solve 2 ln x plus 1 equal to 5. So the first thing you do, you could just take the plus 1 on the other side. So it would be 2 ln x equals to 4. And then you could divide the 4 by the 2. Then you'll just have ln x equals to 2. So that's just basic algebra rearranging. And now to get rid of the ln, we simply just take e on both sides. So e and ln x will just give you x. And then you have to take e on this side as well. So it'll be e to the power of 2. So x equals to e squared. So we said e to the x, if e to the x equals to 5, and we want to solve this, we could just take natural log on both sides. And remember, natural log is to the base e. And using the power law, we know this is just x log e equals to log to the base e5. And if you recall, if the base and that number is the same, then they make 1. So you could see it's actually equal to x equals to log e to the 5. So it is fine to leave your answer as exact values. So e to the x equals to 5, we could take natural log on both sides. So rather than taking log to the base e, so we could just take log, natural log. Now we said natural log and e will cancel out, so x equals to ln 5, just like what you've got there. So it's another way of looking at this. So obviously this way, using natural log, it would be a more easier method to use. Okay, so you solve this one, pause the video and have a look at this. So in this case, we just take e on both sides. So e to the power of 3 is equal to x. Because if you have ln x equals to 3, to get rid of ln, you just take e on both sides. E and ln cancel out, gives you x, and you have e to the power of 3. Now pause the video and have a go at this one. Yeah. So first of all, we could take ln on both sides. So we know the exponential and the ln will cancel out. So 2x plus 3 equals to ln 7. We subtract the 3 and we divide by 2. So that'll give us x equal to half ln 7 minus 3 over 2. Okay, so have a go at this one. Pause the video and have a go at this one. So you'll see this is the same question I put up earlier. So here you subtract 1, so you get the 4, divided by 2, so ln x equals to 2. And because you want to find out what x is, you can get rid of the ln by taking e on both sides. So e squared will equal to x. Okay, so let's have a look at this one. So first thing we could do is subtract 14. So we get this something look like a hidden quadratic. And we could simply factorize this, because if you look at e to the power of 2x and e to the power of x, you could take e to the x plus 7 and then e to the x minus 2. It's very similar to think about quadratic. If you had x squared plus 5x minus 14, you would take the x here. So in this case, you're just taking e to the x. If you find this idea difficult, you could always write it using y equal to e to the x, and y squared would equal to e to the 2x. So now we've got two possible solutions for e to the x. E to the x equal minus 7 or e to the x equal to 2. But think about e to the x. That's an exponential graph. And if we go back to the idea of exponential graphs, it's asymptote at the line y equal to 0. So you'll never get negative. So e to the x equal to minus 7 is not applicable. So what we're interested is on e to the x equal to 2. Now to find out what x is, I could just simply take ln on both sides. So x would equal to ln 2. So here are two questions. All I need to do is pause the video and have a go at these two questions. So the first one, x equals to ln 3. If we look at the second one, because we got e to the power of minus x, we could rewrite this as e to the x minus 2 over e to the x equals to 1. Remember, negative power, you could take that at the bottom and get rid of the negative. And now to get rid of the e to the x, we could simply multiply everything by e to the x. So e to the x times e to the x, so that will give us e to the 2x minus 2 equal to e to the x. Because the 2 over e to the x times e to the x, the e to the x cancel out. So now you take the e to the x over from the right hand side to left hand side. So you'll have e to the 2x minus e to the x minus 2 equal to 0. And now you could factorize. So you'll have e to the x plus 1, e to the x minus 2 as your two factors. So e to the x would equal to minus 1, or e to the x would equal to 2. But we know, as I said before, that e to the x equal to minus 1 is not applicable, because exponential is asymptote at y equal to 0. So we're only focusing on e to the x equal to 2. So if you just take ln on both sides, e and the ln would cancel out. So that leaves you with x equals to ln 2. Okay, so here are 3 questions. So you guys pause the video and have a go at these 3 questions. So here's the answer to the first one, and it's fine to leave it in exact form. The answer to the second one, and the answer to the last one. This one, remember, is a product, and then you could use the log rule to write it as a plus. So ln 2 to the power of x plus ln e to the power of x plus 1 equal to ln 3, and then go from there. Okay guys, so next lesson we'll move on to working with logarithms and nonlinear data. So for now, that's all done. Until then, take care.